The following tests were conducted to analyze the strengths of different orthoses when subject to plantar flexion loads. The orthoses were made of various materials and of different designs. The tests were performed by applying a load in a manner that would force the foot plate of each orthosis into plantar flexion. Two different tests were performed. The first test checked each orthosis for plantar flexion resistance without modification to the basic structure. The second test was conducted on those devices that could be adjusted to increase plantar flexion resistance after using the manufacturer's suggested procedures or accepted orthotic practices. Each orthosis was attached to the testing unit in the same manner in order to isolate its ability to resist ankle-foot plantar flexion. By imposing specific and uniform plantar flexion beyond a 90-degree start point, the test unit was able to display the amount of mechanical force provided to offset ankle-foot plantar flexion in the patient. The prosthetic leg was made of a wooden core and was to duplicate a male subject. The ankle area is cut and beveled and a free motion hinge installed at the ankle center. This allows the ankle foot to move 40 degrees, 20 degrees dorsi to 20 degrees plantar in the sagittal plane with no resistance other than gravity to the plantar flexion or dorsiflexion. The leg is mounted to a 12 millimeter screw drive mechanism, which provides a steady, uniform pulling point which is centered under the metatarsal area of the prosthetic foot. The digital force gauge provides an accurate digital reading of the force being exerted to pull the foot into plantar flexion. The digital protractor attached to the ankle foot area uses a liquid-filled sensor which displays the ankle's inclination when the foot is in the neutral position, 90 degrees to the midline of the leg. The protractor reads 0. The units that were tested conformed to base code L 1970, an AFO plastic molded to a patient model with ankle joint. Base code L 1920, an AFO single upright with static or adjustable stop, Phelps or Pearlstein type. Base code L 1990, an AFO double upright free plantar dorsiflexion, solid stirrup, calf band, cuff, double bar BK orthosis. Also tested were several non-adjustable heel suspension devices. And finally, the Profo, thermoplastic and metal adjustable single upright AFO with walking base. A review of the test data on the static, non-adjustable, pre-made one-piece heel suspension device shows that from a 90-degree start position, the resistance to 10 degrees of plantar flexion varies from less than 3 pounds to 5.5 pounds. The start position of 10 degrees dorsiflexion to 10 degrees of plantar flexion was unable to be obtained because the unit is non-adjustable. The base code L 1920, from a 90-degree start position, the resistance to 10 degrees of plantar flexion produced by this orthosis was 17 pounds. A start position of 10 degrees dorsiflexion to 10 degrees of plantar flexion produced 23.1 pounds of resistance. The Profo APU, an adjustable posterior upright AFO, from a 90-degree start position, the resistance to 10 degrees of plantar flexion was 12.8 pounds. The 10 degrees of dorsiflexion start point to a 10 degree of plantar flexion was 24.3 pounds. The heavy-duty Profo, thermoplastic and metal adjustable upright AFO, from a 90-degree start position, the resistance to 10 degrees of plantar flexion was 26.3 pounds. From a start position of 10 degrees dorsiflexion to 10 degrees of plantar flexion produced 53.7 pounds. In all, 10 custom-made ankle-foot orthoses were tested for their ability to resist plantar flexion. 4 Profo models were also tested for plantar flexion resistance, as were 8 non-adjustable heel suspension devices that have traditionally been used for the recumbent population. Each of the tests were run 10 times to verify the results. Based on the findings of this project, the adjustable ankle-foot orthoses are capable of providing at least 11 pounds of resistance to plantar flexion. These orthoses also have the ability to provide the additional 10 degrees of dorsiflexion necessary for normal ambulation. Clearly, the Profo family of orthoses not only meets the benchmark minimum requirement as provided in this study, but exceeds the minimum requirements due to the comprehensive adjustable features of its design. The results show that the base code L 1970, the base code L 1920, and the base code L 1990 AFOs all produce in the range of 15 to 20 pounds of resistance at the 90-degree start point for plantar flexion. The pre-made heel suspension devices fell between 2.3 and 5.5 pounds of resistance at the 90-degree position. The Profo family of orthoses showed their capability of producing in excess of 12 pounds of resistance with plantar flexion at 10 degrees. When tested from 10 degrees of dorsiflexion for resistance to 10 degrees of plantar flexion, the base code L 1970, the base code L 1920, and the base code L 1990 again produce resistance in the 20 to 24 pound range. The pre-made heel suspension devices were not tested due to their inability to be adjusted or the manufacturer's recommendation relative to adjusting for additional dorsiflexion. The Profo thermoplastic and metal adjustable joint upright AFO, when tested from 10 degrees of dorsiflexion to 10 degrees of plantar flexion, produced 24.9 pounds of resistance. The heavy-duty Profo, when tested, resulted in 53.7 pounds of resistance under the same conditions.